Thank you for being here. Good morning. That was better. My name's Don Jones. We're going to be talking about PowerShell under the hood. Now, one of the reasons I kind of wanted to do this, how many of you work with PowerShell kind of regular, like? Good, that's the perfect audience. This is definitely not going to be entry-level stuff. Anytime you're working with a tool, it's really, really easy to just kind of get in and use it. Take a car, right? A car is a tool, gets us from point A to point B, and you really don't have to know much about a car to drive it anymore. I mean, my truck cruise control, it turns out, forces you to keep a 3-second distance from the person in front of you. Like, you can't hit the person unless something goes wrong. I'm not sure how you would know if something goes wrong, apart from hitting them. But I don't have to know anything about how all that works. But if you do really know your tools well, like if I know how the transmission in that sucker works, and I know how that tow mode changes how the transmission shifts, I can operate that tool much, much better. I can kind of take my driving with it to a different level. I can get better gas mileage or more power, or I can get it up a hill with 3 tons of concrete in the bed a lot easier and more safely. Like, I can just be better at it because I know how the tool works. And that's what I wanted this session to kind of be. I wanted to take a look at some things in PowerShell that you already know about, you already use it, but I want to dig into some details. Because I feel that if you really know those details, you can do so much more efficiently, like without you working harder, and you can accomplish a lot more. So that's what I wanted to kind of make this into. Before we get started though, please feel free to ask questions. I will try to, if you can make them concise, it makes them easier for me to repeat so everyone else can hear them. So I'll try and repeat them back to you to make sure I get the gist of your question. Think about questions like, why does PowerShell do blah, whatever? Why does it do it that way? Or why doesn't it do this? Or why whatever? Because look, here's the deal. I've been an MVP with Microsoft for 15 years. I just got my 15-year award in July. My career is kind of moving me in a different direction. It's entirely possible that I will not get awarded a 16th year, so I got nothing to lose. Like, I can just answer your questions. I can tell you the truth. If I don't know the answer, I will make up something plausible, just so that we have a good time, right? All right, so let's just dive right in. And the first thing, and there's going to be some demo here if my virtual machine plays along, but some of this stuff is conceptual. So feel free to take notes. I'll try and lay out as much detail as I can on these things. Ask questions if I'm leaving something like unclear for you. But the first thing I want to talk about is objects, and we're not going to spend a ton of time on this. You guys know that PowerShell is an object-oriented shell already, right? Just raise your hand or nod if that's true. I think a lot of times, though, people don't really grasp the power of that. And I think one of the best ways, has anyone run PowerShell core on Linux? A couple people? Take a minute and run PowerShell core on Linux. Just boot up a Linux VM at home sometime, or if you want to, open up an Azure Cloud Shell session, because that is PowerShell core running on Linux delivered via a web browser. That's what that is. And run get-process. Now, I know get-process is not the most amazing command in the world. Like, I'm sure you've all run it on Windows before, right? The difference is that Windows is already an object-based operating system. It's an API system. Everything Windows does is objects. It's just a data structure, right? You can kind of think of it as a spreadsheet. You got rows that are objects and the columns are the properties. So it's just a way to structure data. And Windows does that because it's an API-based operating system. Everything in Windows comes down to an application programming interface of some kind. On Linux, though, the magic of these objects really becomes more apparent because Linux is a text-based operating system. In Linux, everything is basically either a file or a folder. Like, at the end of the day, that's what it makes everything look like. Easy to work with, kinda. You know the one skill that every Linux administrator eventually becomes a master at? Regular expressions. Because you spend all your time parsing these text tables. When PowerShell runs on Linux and you run GetProcess, under the hood, it's actually running some native Linux commands and parsing that text into objects. So you don't have to do grep, sed, awk, regular expressions and stuff. You can just refer to an object and a property, and it'll give you the value, just like you do on Windows. And it's only magical if you think about the work that went into making that happen all the way under the hood. The takeaway from that, ideally, if you're working with PowerShell a lot, you should be writing your own tools, your own commands, advanced functions, right? If you're a C# programmer and you got Visual Studio, maybe you're writing commandlets, compiled commandlets, but at the very least, you should be writing functions. Your functions should exclusively output objects, except in very few exceptions, like if you've written an export command that you want to produce a CSV file or something else, right? Most of your commands, though, should be exporting objects. I see people struggle with that a lot. They get so in the batch or VB script mindset that they focus exclusively at what's on the screen. I just want what's on the screen to be pretty. Screw that. There's lots of commands that can make what's on the screen pretty, provided you've output objects already. I ran into one guy, he said, yeah, I've got this situation where I want to produce a virtual machine inventory from some of my Hyper-V hosts. I said, great, that's a wonderful thing to do. There's a command for that. I think it's called getVM. Super simple. He said, well, but I want to go into each of those VMs, and I want to look up the operating system they're running and the service pack they're on. So I can't just run getVM. I feel I need to start there, but then I output those things, and how do I output the next thing? Think objects. Just take those VM objects, go do whatever other work you need to do, and then add properties to it. So you're just making more columns at the side of the spreadsheet. And if you start to think about objects as a spreadsheet, and you only ever get one sheet, it's not a whole workbook, you get one sheet, and if you can think, okay, these are the columns I want, those are your objects, those are the properties that you want to create and produce. If you do that, PowerShell will start to do so much extra work for you. Yeah, but the reason I'm doing all this text is because my boss needs it in an HTML file. Produce objects, convert to HTML. Export CSV, export XML, right? We've got all these other commands that can take care of these different formats for you if you're just outputting objects. Does that make sense for everyone? If you're using write host, probably doing it wrong, because you're not producing objects that go to the pipeline that way. If you're using the echo command, which is just an alias to write host, you're still thinking like a batch file guy, and it's time to move away from that. PowerShell will let you use it in a lot of different ways, but it works best when you use it the way it wants to be used, and that's by creating objects. There's a zillion examples out there in the world of how to do that. If you need a quick one, a command to look at is new object. It's got some great examples in the help file that show you how to create custom output that contains all the data you need. Nearly every book I've ever written on PowerShell has tons of examples. There's free videos up on YouTube under the PowerShell org account that goes into this. It's like a well-known science. But if you're still kind of coming from the VB script or the batch days, then you're not really taking full advantage of what the shell can do. Make sense? How many of you use PowerShell remoting? How many of you know how it really works under the hood? One guy. Perfect. You can go. Just kidding. Who wants to know how it works under the hood? It's actually really cool. So let's do that next. It's actually a stack of, come back. It's actually a stack of protocols. At the very, very tippy top, well, actually let's start at the very, very bottom. There's a protocol called PSRP, the PowerShell Remoting Protocol. This is a protocol that only PowerShell understands, and when you do remoting, the two copies of PowerShell are exchanging traffic in PSRP. PSRP is encrypted. It uses a shared secret encryption. It's encrypted by default. The next layer up, so what PSRP hands off to is either WinRM, if you're using that stack, or SSH. because PowerShell remoting now supports either of those as a carrier. So the PSRP, which is the same in both cases, so we're down at the bottom there, or at the top, that gets handed off to either WinRM, Windows Remote Management, which implements an HTTP-based protocol called WS Management, Web Services for Management. Under the hood, it's all XML. It's very, very XML-ish. It's a SOAP-based protocol. Or on the SSH side, it just gets transmitted literally over an SSH channel. WinRM can run over HTTP if you're insane, or it can run over HTTPS. What's the big reason? This is a trick question, so think about it. What's the big reason for using HTTPS? Encrypted? Nope. Encrypted is a side effect. The real reason we use HTTPS is to authenticate the guy on the other end. It's so that we know who we're about to send our credentials and commands to. When you go to a website over HTTP, just because it says Amazon in the title bar doesn't mean you're actually talking to Amazon. The whole point of HTTPS is really about identification. Look, if I'm encrypting something, but I don't know who I gave it to, does it really matter that I encrypted it? So HTTPS is what gives us authentication. It means I know the server I'm about to connect to. That's why it's insane to not use HTTP. I'll argue with folks like, well, I'm just going to use HTTP, but it's all internal traffic, and our network is super, super protected, and no one can ever break into it because everyone says that. I'm like, well, it doesn't matter. All I have to do is get a man in the middle, and I can now intercept all of your administration traffic, learn a ton about your network because you didn't know you connected to me because you didn't authenticate the person you were connecting to. You want authentication to work both ways, and that's what HTTPS does. SSH does the same thing through basically the same protocols. It just isn't HTTP. It uses the same type of and that's why SSH does that, is so that when you hit the remote server and you start typing in your password, you know it was the server that you meant to hit, not some guy sitting in the middle spoofing you. Over WinRM only, PowerShell is capable of using Kerberos and other protocols. Kerberos is the primary one, to delegate your credentials. And this is a thing that I think a lot of information security people don't fully wrap their heads around. In a domain environment, how many of you use Active Directory? Did that get popular? Oh, good. In a domain environment, between domain members, so that includes trusts and all that stuff, PowerShell does not send your credentials across the network. It doesn't send a password, either encrypted or otherwise. The remote end goes to the domain and gets a ticket for you. That's what you're sending. You're sending a ticket along. So whatever you ask the remote server to do will impersonate you. Technically, it's not impersonation because it can't log on as you because it doesn't have your password, but it's doing it under delegated authority. So it will only be able to do what you are already allowed to do. And it's a really, really powerful system. If you don't have a domain, or you're using SSH instead of WinRM, you have to pass along a credential. You have to provide a username and you have to provide a password. And the remote end is going to impersonate you. It will log on as you and create a security token as you. If you're passing a credential, a password, across the network, what are we concerned about? Someone stealing it, right? I could sniff it off the network. That's why by default, remoting will only allow that if you're using HTTPS or the SSH stack to make sure that that is as encrypted as possible and so that the remote end is authenticated so you're not handing your password off to a stranger. The last thing I'll say on this, how many of you guys use the computer Security Institute benchmarks for securing in your, a couple folks. Level 2 suggests that you disable PowerShell remoting. And I run into there was a conversation on Twitter, which included one of the guys who helps run that institute, about, what do I tell my security guys? Because they say that we have to disable PowerShell remoting. Level 2 is for machines that cannot be remotely managed. Like, it's one step below unplugging the Ethernet cable and air gapping the machine. That's literally the point of level 2, is that you only want it managed by someone physically walking up to the console and touching it. If your organization is implementing level 2 and asking you to do remote management, they're dumb. And you should question your life choices. And you should certainly question their life choices. Ask them why it is that they don't want remote management, and there might be a good reason. I mean, there's plenty of workloads where you don't want that. Like if you work for NORAD, I imagine they don't like a lot of remote management. But the only reason you follow level 2 is because you need that level of security. You want people touching the machine, which seems like a stupid thing to want for like your Exchange server. There are organizations that would just say, no, we want to do level 2 because it's higher than level 1. I mean, we don't really do security on a number line. It's not better just because it's one more than one. So you can have that knowledgeable conversation. So authentication, again, works the same kind of either way. The future-proof option, and this is kind of new thinking, since we've now got PowerShell Core, right? Your Linux machines can't do delegated administration through Kerberos. That's a Windows thing. So as you start thinking about remoting now, start thinking about doing it over SSH instead of WinRM. That, incidentally, can be a fun way to talk to the security people. No, this says we have to disable WinRM. Okay, cool. We can have SSH though, right? Oh yeah, sure, SSH is fine. That's fine. We know how that works. Oh, great, cool. I can do remoting over SSH. You don't need the WinRM service. You just need your SSH bits. And it works great. It works cross-platform. It's really cool. It's wonderful. You can have both implemented at the same time, actually. And when you make a connection, you can choose which one you want to do. Has anyone set up remoting over SSH? A couple of folks. Works, yeah? Yeah, works a charm. For troubleshooting, get to know the ports involved, 5985 and 5986 by default. 5986 is WinRM over HTTPS. SSH is SSH. It's whatever you set it up to be. So it's just the same good old SSH that everybody's known and used for years. You can sniff these things. You can use Wireshark in its HTTPS mode. So if you've set up an HTTPS endpoint for your WinRM connections, did you know you can import that certificate into Wireshark and it can capture and decrypt the traffic? So you can get to know what normal remoting traffic looks like, and then when there's a problem, you can spot the differences between normal and what you're getting right then. There's a book, free, it's a free book, it's on PowerShell.org on the ebooks menu called Secrets of PowerShell Remoting, that includes protocol stack dumps of what remoting should look like, and it walks you through the entire remoting process from beginning to end. And like, if this is going to be the protocol that you use to manage your network, and it should be, then you need to know how it works. How many of you are still largely managing your servers with remote desktop? Please stop it. Man, that is rough on server memory. That's why we have to reboot our servers, and why Linux kids never do. So anyway, that's all there. The PSRP, which remember, this is the same regardless of the stack you're using to transmit it. PSRP relies very heavily on .NET Framework's built-in XML serialization, which means when you run a command and it produces objects, .NET asks the object itself to create an XML representation of itself. It's called serializing. That XML, this is just text, that gets transmitted across the network, and your copy of PowerShell deserializes that back into a static object so that you can work with it just like you would work with anything else. The reason I like to point this out is because you got some objects out there in the world that do not serialize themselves very well. Anybody use SharePoint? There's a well-architected piece of software, can't we all agree? It gets really dicey over remoting, like really dicey. Like it's worth just turning the machine off and going home, which is about the best way to run SharePoint if you've not tried it. Just be aware that you will run into areas where it just doesn't work well, and it is not PowerShell's fault. It's the fault of the people who wrote the other thing, so that you know who to blame. Cool? Questions on the remoting stack? Like anything about remoting that you've always wondered, this is the time to ask. All the way in the back.
Does that mean if you have to use PowerShell to manage something like SharePoint, it's better to do it remotely? I mean, if you have to?
Yeah, if you have to use PowerShell to manage, so what I would normally do is I would write a complete script to do whatever I want, use remoting to push that script to the SharePoint server and let it run there, entirely there, like get all the stuff done, and then just send me some custom object that I made with whatever data I needed back from that, so that I'm not trying to return a native SharePoint object, because those are the ones that sometimes get a little funky. A lot of it has to do with how SharePoint has to manage its memory in its head, because it's such a well-architected product, and you can only do so much to fix that well architecture.
You don't have to give a full answer, but are there different patterns we should know about when we're remoting as opposed to when we're working locally?
Are there different patterns that you need to know about when you're working remotely versus locally? A couple. One, if you're going to ask a remote server to do something, try to get the remote server to do as much as possible. Let's say I want to do some stuff with Active Directory. You know which machine has the fastest connection to Active Directory? The domain controller. So rather than querying it for one thing, dragging a bunch of data over and then doing something with it, I'm going to let it do all of it. And I'll just bring back my final outcome that I want, because it's going to be faster at it. So that's kind of a pattern, is to recognize that you're doing distributed computing and let the remote nodes do the best that they're going to do. The other is with authentication. So in a domain environment, if I've hopped over to a domain controller and asked it to do something, it by default can't go anywhere else. It can't access any network resources. Meaning, I can't tell a domain controller, hey, I want you to go pull together this big report of users, and then I want you to export that to a CSV on that file share. It can't get to that file share because it's not allowed to take my credential any further, right? How many of you have kids of driving age? So you occasionally have to give them the keys to the car. You're okay if they just hand those to their friends, right? Not so much. Same idea. I can delegate the keys one step, but they're not allowed to delegate it any further. So you've got to be a little careful. Whatever you ask the remote machine to do, it needs to only be using local resources to itself, and then send you results back, and then you can do whatever you need to do with those results. If you're in an impersonation situation, which would be SSH or anything outside of a domain, that's not as much of a problem, because the machine is actually logging on as you, and so it gets all of your ability to go out to network resources and stuff, which is why, as a future-proofing thing, I've tended to start using SSH and just passing credentials. I had one fella, you know, it's really dangerous to pass credentials. That's weird. The Unix people have been doing it for like 40 years, and no one died. So we just need to encrypt it.
So just because you mentioned the impersonation, if I want to track down who ran a PowerShell script, in what logs am I going to look at?
Yeah, so let's just talk real quick about PowerShell logging, because this applies locally as well as for remoting, and it's a good thing to know about. PowerShell 4 and later, and definitely 5 and later, are capable of doing some incredibly detailed logging. Go in the event log. So if you get into the new event log, like not the original security application server, but the new ones, there is a PowerShell log, and that's where you'll find these. It's turned off by default. You need to push a registry key out, which you can do via group policy or however else you want to hack it in. But if you look up PowerShell detailed logging, you'll find exactly what you need to turn on. And it will show you, it's basically a transcript. It will show you who ran every single command, and it will show you the entire command text. There's another level of that you can engage called script block logging, because creating an encoded script block is kind of a bypass to the logging, so you turn that on. And that way, if there's a piece of malware trying to do something hinky or some just like really smart admin, it'll capture that information too. Lee Holmes, who was the security member on the PowerShell team, has done extensive stuff about it. In fact, if you go to youtube.com/PowerShell.org, I forget which PowerShell summit Lee spoke at, but he did like a 2-hour session on PowerShell logging. That was just epic. It's worth watching. And all that lurks under the hood in PowerShell core too. So you can do all that on Linux and Mac.
Yeah, a conversation you and I had the other day, and I feel like it was really interesting about plant control systems. Remoting with Windows 2003 is something that you told me you have to have at least version 2, and you could put version 2 on there to do that. Is that correct?
Yeah, I won't repeat the question, but I'll make sure you get it. Remoting was introduced in PowerShell v2. Any machine capable of running PowerShell v2 can do remoting. And different versions are very happy to talk to one another. Do you guys know who Jeffrey Snover is? Good. He has this thing he does. He did it on stage at Ignite one time, and it was so funny, it disrupted the entire session. Because somebody asked that. They're like, if I'm running PowerShell 4, but I've got this old Windows Server 2003 machine running v2, can I remote from v4 to v2? He's like, yeah. The PowerShell remoting protocol has a thing in it. It's like two dogs sniffing each other's butts, and they just figure out who's what. And I'm like, okay, that's in my head now. We stood up a website called snoverisms.com to capture those little nuggets that he'll spew out occasionally. They're quite fun. But yeah, so you can do cross-platform. The difference, the trick, the only caveat here is if you're running PowerShell core on Linux or Mac OS, it is fairly tricky to get the WS-man, so the WinRM style of remoting set up on those operating systems. Very possible, very tricky. It is very easy to get SSH set up on them because it's there already. But in order to do remoting over SSH, you've got to have Windows PowerShell 5 or PowerShell Core. So you will wind up using both protocols if you've got an extensive number of versions floating out. PowerShell v2, 3, and 4 only do the WS-man WinRM style. They don't do SSH. PowerShell 5 can do both. PowerShell Core can do both, but it's trickier to set up the WinRM WS-man stuff on a Linux or a Mac box. So just be flexible.
Should we not enable CreditSSP then?
Should we not enable CreditSSP? It'd be great if you didn't enable CreditSSP. It's a problematic protocol. It's really just NTLM. And we don't call it that because everyone would immediately turn it off and never touch it. But that's basically what it is NTLM. It would be smarter, I have come to believe recently, to switch over to passing credentials over HTTPS and letting the remote machine impersonate me rather than asking it to use a delegated credential that creates all the multi-hop problems. I was very much the superstitious, I don't feel good about passing my credentials across the network, even encrypted, except that the Unix people have been doing it since the beginning of time, and no one died. So encryption works, it turns out. The neatest thing in remoting, by far, let me just check. Yeah, see, he's still trying to connect. The neatest thing about remoting that I think is an absolutely underutilized thing that I wish everyone in this room would take the time to master is a constrained endpoint. Now, there is a toolkit that Microsoft made called Gaea, J-E-A, Just Enough Administration, that makes it easier to set these up. But you can set them up entirely on your own. In fact, Secrets of PowerShell Remoting walks through an example. When you remote from machine A to machine B, there's a default endpoint called Microsoft.PowerShell that you connect to. That's just the default, though. You can create and name as many endpoints as you want, and when you go to connect to a server, you can specify the endpoint you want to connect to. The default one allows anything to happen, provided you have permission to do it, but it only allows administrators and members of a remote administrators user group to connect. So it locks down who's allowed to connect to that wide open endpoint. You got to be a local admin or a member of the remote administrators group. That make sense? When you set up your own endpoints, you decide who is allowed to connect. You could allow the help desk. You decide what commands are allowed to exist in that endpoint. You can lock it down to one command. If you combine that with something called proxy functions, you can lock it down to the parameter level. You're only going to be able to run this command with that parameter, and you can only specify these 3 values. And you've got to be a member of this group to get in, and the endpoint can have a run as account attached. Meaning whatever commands get run with that account. So how many of you have had that situation where I need the help desk to do something they don't have permission to do, and I don't really want to give them permission? This is how you do that. You let them remote in, and you can write a little GUI on top of it, right? You can use Sapien Visual PowerShell Studio. You can create a little menu, whatever you want to do. And when they do whatever they're doing, under the hood, you just remote over to this endpoint and you run commands. But they only get the commands you allowed them to have, and they can only use them in the way that you set it up. And this way, you're not putting hard-coded clear text domain admin credentials into a script. The credentials are stored server-side as part of the endpoint in an encrypted store. I've worked with companies that, you guys know what a jump server is? So you kind of go to the jump server and it sits in the data center, and then you do all your stuff inside the data center from that. They've got jump servers with 5,000 or 6,000 endpoints, because each one is customized and locked down to a very specific task. You can build these things so that every time someone connects, it automatically runs a startup script. Hey, I was just connected to by this guy at this time, and I'm going to send that off to a database or whatever else. Like, you can create a really robust delegated administration situation here. It's really powerful and flexible. It's really cool too. So all those situations where you're like, yeah, I need somebody to be able to do something they don't have permission to do, this is how you solve that. Make sense?
How do we administer this? What resources are there?
If you look at Secrets of PowerShell Remoting, it walks you through the manual way of setting that up. And then in the PowerShell gallery, there's the Gaea module, which gives you, basically it gives you a bunch of commands to make all this easier to set up than doing it manually. And those commands are documented, they've got help, they're supported by Microsoft, the whole deal. There are two, if you hop on the Goog, and you Goog for PowerShell Gaea, G-E-A, there were 2 versions of this. The version that was written for PowerShell v4 required desired state configuration. They ditched that and rewrote it so that it's just a bunch of standalone commands. So if you find yourself reading an article about Gaea, and it's, by doing this, you set up a DSC config, nope, you've got the old version. Just re-Goog and look for something more recent. Cool? Questions? Like, this should solve every single delegated administration problem you've ever had. If you can do it with PowerShell, you can do it in here. And it's awesome. You will need to play with it a bit, because there's different language modes, and you'll find yourself trying to lock it down too much and it won't work, and then you'll have to back off a bit. That's cool. We all go through that. You'll experiment a little bit with it, and then you'll kind of figure out what's going to work precisely for your situation. But man, the security guys love this thing. It works with the logging that we just talked about. So things are still logged if you've enabled that. Like it's cool. It's cross-platform. This works on PowerShell core. Okay. Hang on. I'm trying to see if you little bastard. Let's try and let that reconnect. Oh, yay, it worked. Yes, I'm sure. All right, can everyone read that? Let's make the font a little bigger for you. Is that sample readable? You in the back? You guys got good glasses. All right, so I want to talk a little bit about the PowerShell pipeline. I know you guys know what the pipeline is. And for those of you who were in my session yesterday, we did this a bit, but this is a chance for me to go in a little bit more detail. It can be incredibly useful to see the pipeline happen. Like it's this invisible under the hood thing, and it can be difficult to understand it and troubleshoot it sometimes. So the example I used yesterday, and I'll use this one today, is, well, let's start with this. If I run GetProcess minus name s star, what's that going to do? Get all the processes whose names start with S, which always winds up being service host. Hi, David. So here's what I want to do instead. Let's do that string. Let's do another one. So in PowerShell world, that's creating an array of 2 elements, right? Would a white background be better? Yeah, you know, the problem is, let's do a black background. Screen background black. See, it does this thing because of PS readline. It really wants to use that. Well, that's S star and D star in quotes separated by a comma. Make sense? An array, 2 things. If I pipe that to GetProcess, what am I expecting to happen?
That's going to get like its name.
It looks like I'm expecting that to go get all the processes whose names start with S or D, right? Let's see. We're going to trace that command. That will be our expression. So we're going to put it in curlies. I want my output to go to the host. You can also have this go to a file. Actually, you know what? Let's do that. Let's do ps path c output.txt, because then I can pull it up in Notepad and we can control the colors a little bit better. And I want to get the parameter binding. I know that runs off the screen a bit. I swear it says parameter binding, promise. Because I want to see what it's doing in the pipeline. So I'm going to run that. I got some errors, which is cool. But now let's open that up. And we'll, jack the font size up a bit here too. This is a lot of output, and there's about 3 dozen things, I think. It's not quite that many, it might be 2 dozen, that I could have traced. I only traced one thing. I want to see the parameter binding. I want to see what values are being attached or bound to which parameters. So there's a ton of information here, but we'll kind of go through it. Oops, too far over. So the first thing it's going to do is bind named command line arguments for GetProcess, meaning, did I type GetProcess and did I specify some parameters? I didn't. But this is an important lesson. If you provide parameters, they go in first. Everything else has to come later, which means if you are expecting the pipeline to be passing information, but you have manually specified, the pipeline won't be able to work because this named arguments get bound first. Now, that didn't go on for very long because I didn't provide many. So the next thing it's going to do is check to see if I've specified all the mandatory parameters, and that works. And then it's going to kick off a section of the command called begin processing. Now, GetProcess doesn't have anything in there, apparently, so it did it. Now, we're on to binding the pipeline object. So what is the object in the pipeline? It's a string. What was the first object I piped in? S star, in quotes. That's a string. So it says, okay, I'm going to bind that input value to the parameter input object. That is not what I expected. I thought it would bind it to name, but it didn't. So that means I'm wrong. And this is an important mental thing that I had to come to early on in using PowerShell. Regardless of what I want, this is what it's going to do. This is what it was programmed to do. And you can spend a lot of time going there, staring at it, asking, well, why didn't they do it differently? I don't know. This is what they did. This is what it wants to do. And so it bound that. Interestingly, because input object is willing to take multiple items, it must have an array. So PowerShell is going to take the one object I've piped in so far and turn it into an array of one element so that it can try attaching it. See, right here. Oh, look, it isn't an array, so I'm going to make it an array. And there I'm binding argument to $$ to parameter input object skipped because it didn't like it. It didn't know what to do with it, and so it rejected it. So we'll try computer name. Nope. We'll try name. See how these are actually binding? They're not binding by value over here. This is what I wanted to happen as my name parameter, but it is only accepting input from the pipeline by property name. I did not give it an object that had a property called name, and so this didn't do anything, and that's why the whole thing fell apart on me. Because there's two different ways for data to flow through the pipeline, and I didn't do it the way I needed to in order to get the outcome that I wanted. So I would have to change how I wrote the command. This is a super, super useful tool to understand why the pipeline isn't doing what you want it to do or why you're getting weird results. Usually it's a data type mismatch or the parameter was not rigged up the way you expected it to be to accept pipeline input. Does all that make sense? When you're testing something like this, quick tip, I used 2 pieces of input data. Try and limit it. Because after it does this entire process for S star, it does it again for D star. Because items go through the pipeline one at a time, alone, just like us in this hard, cruel world. Right? There's no footprints to help them along. So if you were to put like 500 input values, your trace output is going to be quite long. And you will get bored, and you will not want to watch it. But it is nicer to pull it out into a text file like that than to just spew it all to the screen. Questions? Answers? Would anyone care for a mint? No? Okay. So that's the pipeline in action. Let's talk about the formatting subsystem. When they were writing PowerShell, they knew that it was going to be an object-oriented shell. And we, as people, can't really comprehend a data structure that is it's a very abstract thing. It happens in memory of the computer. At the end of the day, we want to look at something on the screen, right? Or put it on a printer or stick it in a like we are people and we need output on the screen. So they knew that they were going to have this formatting system that could take an object and make some reasonable textual output for our frail organic eyeballs. And so Jeffrey sent a guy off on the team, said, you go develop the formatting subsystem. And then forgot about him for several weeks, and he went a little sideways. So what we've got is an incredibly complicated system to generate fairly non-complicated results. When you run a PowerShell command, invisibly, at the end of the pipeline, there's a command called out default. It's always there. You can't stop it. What out default does depends on the hosting application that is actually running the PowerShell engine. In the console app, out default is hardwired to a command called out host. Now, what do you think that does? Puts output on the screen. So whatever happens to be in the pipeline at the end of your command, might be nothing, might be a whole bunch of stuff, goes to a command called outhost. Outhost doesn't know what to do with normal objects. So it calls on the formatting subsystem, which has a whole bunch of rules around what it's going to do. I'll show you what those rules are, because they're kind of fun to play with. No, don't save that. That sounds like a terrible idea. I'm in the PowerShell installation folder. $PS home is a variable that contains that path, so it's a quick way to get there. And if, that's not the command. If you do a dir, see all those files that end in .format.ps1xml? Those are the predefined views for hundreds and hundreds and hundreds of different types of objects. Processes, services, certificates, all kinds of stuff. So when outhost needs to display something, the first thing it does is it looks in one of these files to see if they contain a predefined formatting view for whatever type of object it needs to display. Sometimes that can be complicated. When you run dir, what types of objects are you expecting to see in, say, the file system? It's not a trick question. Files and folders. Wait, files and folders? Those are two different things. And so, if you look, let's see if I can point to it. Yeah, diagnostics, file system. See it right there? File system.format.ps1xml contains this extensive XML blah that basically constructs the display you see when you run dir. That's how that happens. You can get in there and change it. You can ruin it. You can make it so that directories will never display again. And you'll have to go get a copy of that file from someone else and put it back. They used to sign these. They don't anymore. Cool, right? You can make your own. You can totally override what the shell does by default. Now, if it doesn't find a layout in one of these for whatever object it is you're trying to display, and that will be the case if you created a custom object. It's not going to be there. It has a really simple rule set. Are there 5 or more properties? Sorry, 5 or fewer properties, it will construct a table. So you'll get columns. The theory is whatever you're displaying, 5 columns will probably fit. Now, this was all designed back in 2005, before we had monitors that are this big, right? So if you've got a monitor this big, and you've got the shell window this big, it will be column, 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 with lots of space in between. If you've got more than that number of properties, it just makes a list and puts every property on one line, and it scrolls forever and ever and ever and ever and ever. So do you want to see what these look like? Because you can totally mess with them. Just, play along. We're here. Notepad. I like to play with the .NET types one because this has got most of the stuff in it. And then let's just go look for system .diagnostics, .process. There we go. When you run GetProcess, this is what tells it what to do. It specifies that it should create a table. The first column is going to be handles, and that will be 7 characters wide, and so on, right? This is where that display comes from that you're probably very accustomed to looking at. Once I scroll down past the column headers, here are the rows. The first column is going to use the handle count property. The second column is going to take the NPM, non-paged memory property, and divide it by 1024, and then cast that as a long floating point number. Rather than just showing you the full number, it's going to take it down to kilobytes. Cool, right? So you can do calculated properties. You can write these things yourself. You can create your own, and you can actually override the ones that are in here by loading yours afterwards. It's like the last guy in is the one who wins. Yeah.
Do you recommend messing with the default ones or kind of copying?
I'm scared to mess with the default ones, honestly. I did it once and I broke the universe. So I will usually copy this, where am I? This line here is the end of the view. And then back up at the top, you'll see the opening view tag. Right here. The name is actually arbitrary. You can call it whatever you want. This is the bit that makes it work. You have to know the type name of the object you're trying to format, and you can get that by piping the object to getMember, and it'll show you the type name. And that's what triggers it. That's how it makes the match. I've actually got a friend of mine, and I never would have thought of this, but he needed to produce some very specific on-screen output of, I actually think it might have been processes. I think they were doing some process monitoring on some web boxes. And he said, before I show you what I did, I want to ask what, you're Don Jones, you wrote the book. What would you do? I said, I'd probably write a script or function, and I'd go get the data I wanted, and then I'd construct my own object that had the data I wanted. He said, yeah, I didn't do that. I'm like, well, okay. He said, all the data I want is already there on the object. It's just not all displayed by default, and I need some of it to be like in smaller columns or water. He said, so I just made a view. I made a view, and at the top of my script, I load that view, and then I run the command, and now my view is the default output, and then I unload that. I'm like, that's totally valid. I never thought of that. And it's a really way to get well-defined, because you can control alignment, left and right. You can control the width. The only thing you can't do with this is color. Remember, Jeffrey sent the guy off to do the formatting system and forgot about him for a few weeks. If he'd have forgot one extra week, we'd have color. But that's when Jeffrey's like, hey, did you do that formatting system? Holy God, that's huge. Enough, stop. And here we are. Fun story, though. All right.
Do you save that view as a file and then just include it in script?
Yeah, you can save it as a file, or you can actually you can do a here string with the XML itself. I usually do a file. It's just easier. And yeah, you just bring it along with the script. Yeah. A lot of folks don't really grok the complexity of the PS drive and PS provider system. So I want to highlight this for just a second. And there is, incidentally, an open source framework called SHIPS, like ships in the night, SHIPS. It was written by Jim Christopher, who's a former PowerShell MVP, and a colleague of mine at Pluralsight. And SHIPS lets you write your own PS providers in PowerShell. Now, I'll show you what that looks like. I'm going to do a get PS provider. These are the providers that get loaded by default. A provider is an adapter. It makes some form of storage look like a file system, meaning it knows how to get things, it knows how to remove things, it knows how to do new things, like all the things you would do with the file system. And so this is how PowerShell is able to talk to the registry. It uses this type of thing to store its own aliases and functions. This is how it talks to Active Directory. Like when you load the AD module, you can map a drive to a different domain. It maps one to your logon domain automatically. But if you've got other domains, you map a drive to the other domain, and that's what holds your authentication context. And then you change to that drive to perform operations in that domain. All the Active Directory commands default to whatever domain you're attached to at the moment. So if you've got some customer database, custom situation stuff happening, you could easily write yourself a PS provider, and when you run get PS drive, you can see which provider each of these drives is actually using. My C drive is the file system. I've got two registry drives. They're mapped to HKey current user and HKey local machine, HKCU and HKLM. SQL Server implements one of these things. Active Directory does. IIS does. So it's a great way to expose hierarchical style data in particular, although it could also be flat data. The environment variables, the env drive, that's a flat data store, as is functions and variables and aliases, so it doesn't have to be hierarchical. But it's a really cool way to work with data, because once you've written the PS provider, we all know how to manipulate the file system, right? How do we get a list of things? Right? Get child item. GCI, not LS. You guys got to quit using LS, because if you do that on Linux, it's actually the real LS. It's not an alias to get child item, because they were trying to be respectful of the Linux people who've done so much for us. But this is a really neat way, because you can also provide different credentials. And if you look at the top of this list, different providers can implement different capabilities. Do you see the one provider that supports transactions? It's the one that says transactions. It's the top, first one on the list. You with me? Registry. Since Windows Vista, the Windows registry has been transactional, which means you can run a command called start transaction. You can make 100 changes to the registry using that transaction, and then get to the end and go, oh crap, that'll wreck the whole server. And you can revoke the transaction and it'll all go away. Or you can commit the transaction and it'll all happen at once. Cool, right? So there's a lot of neat little capabilities in here. The file system supports mapping new drives using credentials, which makes a ton of sense, because when we talk to file servers, we often need to provide credentials. The registry provider doesn't. You can't map a drive to a remote registry. You know why? They never got to that. There's like a lot of loose ends in the product. This is a really cool set of stuff to know. Like that this is in there. Most of us only use these for the file system, which makes sense, it's fine. But you can do so much more once you realize this is there and it's structured like the file system. But be aware that not everything will work in every place. For example, in the file system, could I do get-child item minus filter and then provide some filter criteria? Would that work? It would work, because the file system provider supports filter capability. What if I did that in the registry? Blows up. That provider does not support filtering, because the registry is not indexed. So it can't do filtering. It has to do brute force, look at every single thing and see if it meets criteria. That's not filtering. Cool, right? So if you've got some questions coming up, we're getting to like the 15-minute left marks. This is a good time to start thinking of them. Actually, if you've got some in mind, go ahead and ask before I do my next bit. Really? You're not being very supportive. Like there's nothing in PowerShell you've wondered, why does it do it this way? Or why doesn't it do it this other way? There's nothing about PowerShell that annoys you. That can't be true. Come on.
I guess I have a question, but it's kind of off topic.
Okay. I love off topic. Let's do it.
Just getting access to, I guess, WMI, CSI, the .NET stuff, and getting away from some of the packaging that PowerShell is put on those things, I guess.
Okay. So your question's more like, so WMI, forget about, and that includes SIM, because those are all native code. In fact, the SIM repository is kind of the way that a C++ programmer extends PowerShell, because they're C++, and you don't have to write managed code. So if you want to get to SIM, you're going to use the commands. But if the question is, look, how do I get the .NET framework? Just get to the raw .NET framework inside PowerShell? You use new object to instantiate a new object, and then you go code against its methods and stuff. Let's be really clear. All you're doing is writing C# code. Like, it might be easier just to use Visual Studio and write C# code, because you're going to get better, tab completion and auto completion and IntelliSense and all that garbage in the environment it's designed for. But yeah, you can do that. I see lots of people do that. Understand the point of PowerShell, though. And we did this a bit yesterday, so I'll keep it short today. The point of PowerShell was not to provide developers with squat. The point of PowerShell was to take something that is very ugly to an admin and make it prettier to an admin. It was to take, PowerShell did not give us a single lick of novel, new functionality. Every single thing PowerShell does is already in the .NET framework. If you knew C#, you could have been using it all along. The point of PowerShell was to take all that stuff and wrap it in a way that was more suitable for administrators and provided a level of consistency that the .NET framework doesn't always have. A good, super trivial example. The object that represents a process, the system.diagnostics.process, the thing we've been playing with, does not have a property called name. Processes in the .NET framework don't have name. They have process name. Services have service name. It's just inconsistent, and it's bloody annoying if you don't have the MSDN docs up in front of you. And so PowerShell adds an alias called name that just points to the other thing, so that everything in PowerShell has a name property. So it's just wrapping things. That's its whole purpose. If you don't want the wrapper, yeah, totally, go against it in C#. I would personally do it in Visual Studio because it's a better environment. But if you just want to be in the shell so you can like bomb off a couple things to try it out real quick or prototype something, yeah, just new-object, give it the class name, Bob's your uncle. But
If you're creating a tool for someone else to use, I would do it that way and give them the function that has a property.
yeah, so if I'm creating a tool, I would absolutely either write it as a PowerShell advanced function, and I would predominantly do that if I was wrapping something that wasn't .NET. Like if there was some command line utility that was spewing some text output and I wanted to turn that into some nice objects, I would do that as a PowerShell function because I'm more comfortable with the string handling there. And let's be clear, that's my only criteria. I'm more comfortable with it. If I wanted to wrap something in .NET that no one had provided a command for, I would haul out my copy of Visual Studio because I'm very comfortable writing a C# commandlet and it will run faster. And yeah, my goal as a PowerShell coder is to write tools that make hard things easy and then back away. Absolutely.
Yeah, I'm basically a PowerShell scripter from operations side of things, and I've now moved into a DevOps role, and I'm working more with DevOps.
Yeah. Write C# commandlets.
Yeah, so I gotta kind of.
And look, let's be really clear. There's a reason PowerShell's scripting language uses the syntax it does. There's a reason it's the curly braces instead of like VB script where it was if and end if, right? It looks a lot like C# because if you've been coding in PowerShell enough, you're like, nah, C# stuff's not so different. It was meant to provide a glide path into a real programming language. It was designed to secretly make you all want to be developers when you grow up. Because it's Microsoft, and in their minds, that's the only type of person there is.
So I wrote a function in, I got the begin process, and I put a variable at the begin statement, and then in the process, I had write verbose with the variable in it, and then I had my command. The write verbose wouldn't display the variable, but the command would. So
Yeah.
I had to move the variable into the process.
Yeah, so we're talking about when you write an advanced function, you've got the begin process and end block. They are nominally all in the same scope as each other, but you do need to understand the order of execution. So, and that order differs when you're running the command with pipeline input or if you're running it without pipeline input. So you guys know what I'm talking about with the begin, the process, the end block in an advanced function? Yeah? So here's the sequence. If you run that command, that function, without pipeline input, meaning you're just running it, it is as if begin, process, and end just don't exist. Those labels aren't there. The function executes from top to bottom as if those labels didn't exist. It only pays attention to those labels if you have piped data in. And when you pipe data in and run the function, the begin block runs before anything gets hooked up to any of the parameters. Begin, and we saw this in the trace output, begin runs after we bind named parameters, but before we bind any pipeline input. So if you're working with a variable and you're trying to grab something from a parameter, it might not be there yet. It's not until we hit the process block that we attach pipeline input to parameters, and we do that each time through the process block. So depending on exactly what you were doing in your code, it's entirely possible that, yeah, something you were trying to set in the begin block just wasn't there yet. But by the time you got to the process block, it would be. They're a little tricky. The neat thing is they provide a glide path to C#. Because if you're writing a commandlet in C#, it's the exact same structure. And it behaves in exactly the same way. Advanced functions were originally supposed to be called script commandlets. They were supposed to be a script version of what you could already do in C#. They changed the name at the last minute for some reason, and here we are. And incidentally, like, if you're looking for a fun career skill to kind of supplement what you're doing in PowerShell, learn some C#. Like, it's not hard. You already know about 80% of it because it's the same syntax as the PowerShell language. It's the same structures. You've got the same logical constructs. They all work exactly the same way. Commandlets get laid out exactly the same as an advanced function. There's no differences. You've just got to learn a little bit more about variable declaration because variables are strongly typed in C#, whereas PowerShell is like, whatever. But how many of you kind of are really good about typing your PowerShell variables? 3 people. Cool. You could do that more, all of you, I guess, but whatever. It's free world. So yeah, you got to get used to the strongly typed variables, and instead of write output, you call a method to send things to the pipeline. Like, it's just minor syntactical differences. The first time I wrote a PowerShell commandlet, a compiled commandlet in C#, I had been writing advanced functions for probably 2 or 3 years. It took me all of 20 minutes of research to find the Visual Studio template that set it all up for you and to figure out how to do write output. It was easy after that. It's all the same stuff. So that's like a good life skill to add on to, because they run faster, right? And you can do so much more cool things with how you do help and you do updates and you do deployments and everything else. They're really, it's a great thing to know. Besides, apparently developers are always going to be able to get a job Not sure about us admin types. So, you know, little hedge to your career. Anyone last question? Why did they, why didn't they? Okay, cool. Oh, yeah, now you're in. Okay, what?
Just on the PowerShell, you showed the console editor there, but what about the scripting environment?
So what about the scripting environment? Yeah, I was just in the console. So you've got two choices. The wrong choice is the ISE, right? Microsoft is done with that. They're over it. They're not taking it away, but they're not doing anything else to it. The only reason Microsoft created the ISE is because they could not get the Visual Studio team to commit the resources necessary to make Visual Studio a good PowerShell editor. And also, they weren't sure if admins, companies, were going to drop a couple grand to get them a copy of Visual Studio. And they needed something nicer than Notepad, so they wrote the ISE. But now we have Visual Studio Code, which is free, cross-platform, and does PowerShell like a monster once you add the PowerShell plugin. So Visual Studio Code is the go-forward script editing environment for PowerShell. It is nicer than the ISE in nearly every imaginable way. You can run it on your Mac natively. It'll run against PowerShell Core on Mac or Linux natively. It runs on Windows. It color codes and indents and does code folding and all the things that we wish the ISE would do, it already does. And it's extensible. So if there's something it doesn't do, the community can jump in and write a plugin and make it do it. So yeah, just use that.
So the ISE, once you save your script, it will automatically auto-save every time you run it?
Yeah.
Why isn't that in VS Code?
You can set VS Code up to autosave.
Okay.
Yeah, the difference is the ISE has kind of a really screwed up proletariat idea of scope, which can make troubleshooting very hard. Like I tell people, if you're going to develop in the ISE, for the love of all that's holy in the world, test in the console. Like whatever you tested in the ISE is not true. VS Code doesn't do that. VS Code, every time you hit run, it's a brand new, fresh run space, so it's a new scope, as God intended for code to be tested. And you can set it up to do autosave. What's better is you can set VS Code up to talk to your source control that I know for a fact you're all using because you're grown-ups, whether that's TFS or VSTS or Git or GitHub. You can hook it up to your source control system so that you can check your code in every time you go to run it or whatever. And you're all doing that, right? Good, excellent. So, all right guys, thanks for being here. I got one more session tomorrow morning. Hope to see you there, and have a great rest of conference.